This is section 2.6. Here we're going to be talking about what's called variation and some applications of variation. So variation, imagine you have two quantities, quantity x and quantity y. As x, let's say as x grows, y also grows. So imagine that x is growing and that it makes in turn y also grow. So we would say then that x varies directly with y. So x varies directly with y. Also, for instance, now I guess the inverse of that. If imagine that you have a situation in which one variable decreases and that forces the other variable to decrease as well. So as my x decreases, my y decreases. We would also say that x varies directly with y. So if two variables grow together or decrease together, then they vary directly with each other. So here they give us some definitions. We have what's called a constant of variation. So it's going to be some number. It's also called the constant of proportionality. It's usually denoted by k. So we're going to probably, in a lot of the exercises that follow here, we're going to be finding this k. Direct variation. Y varies directly as x or with x, or y is directly proportional to x if as y grows, x grows, or as y decreases, x decreases. That's what it means to have direct variation. As one grows, the other one grows. As one decreases, the other one also decreases. Okay, so y varies directly with x means that y equals k. That k is that constant of proportionality times x. Or f of x equals k times x. Yeah, so the way you interpret this, so you can hear it like this: y is directly proportional to x. That just means y equals k times x. Or y varies directly as x. That just means y equals k times x. Okay, so let's see. They give us some little steps here for the following exercises. We're supposed to write down the equation of variation. We solve for k, put k back into the equation from step 1. So let's see. Let's get into the first exercise here. So I want to find the variation constant and an equation of variation in which y varies directly as x and y equals 32 when x equals 2. So I'll help you with this exercise. But if you want to pause the video and try it on your own, by all means. But this is maybe a little bit new. I don't know. Let me help you with the first one. So the first statement, y varies directly as x. What that means is that as my y grows, my x grows as well, or maybe as y decreases, x decreases also. So this is going to, first of all, I need to come up with the equation, which says this: y equals kx. Remember that k is my constant of proportionality. So this is called the constant of proportionality. All right, so that's what they want me to find here. Find the variation constant. The variation constant, that's k. Okay, so now they give me some information that whenever y is 32, x is 2. Okay, so then that means the following. I'm going to replace my y with 32 and my k with 2. And right now, k is multiplying x. So there's multiplication here. Okay, well, if I want to find the variation constant, it's pretty straightforward now. Let me divide both sides by 2. Okay, so then that says that k equals 16. Good, so I have found my variation constant. Now, the equation that I want is just y equals 16 times x. And that's it. That's it for this exercise. We found our variation constant. Also, sometimes it's called the constant of proportionality. And we came up with the equation that kind of illustrates what's going on here. And if you think about it here, what's going on is that if y grows, let's say if x grows just a little bit, like by 1, well then 16 grows by, so if x grows by 1, then y grows by 16. If x is 2, y becomes 32. If x is 3, y becomes 48, and so on and so forth. Yeah, so as x is growing, y is growing. Okay, so now, so we have two scenarios, that as x grows, y grows, or as x decreases, y decreases. Now, the other possibility is that as one variable increases, the other one decreases. That's called indirect variation. So let's see, let's recap what we know. If one variable grows and so does the other one, or one variable decreases and so does the other one, that's called direct variation. If they do the opposite things, if one grows and the other one decreases, then that's called indirect variation. So y, another way to say this is that y varies inversely, or that y is inversely proportional to x. And the equation becomes y equals k. We still have our constant of proportionality, but now is times 1 over x, or just y equals k over x. So let's see. It's similar. It's just that what's happening now is that as one variable increases, the other one decreases. So let's look at the next example. I gotta find it's similar to the previous example. I want to find the variation constants, okay. So I want to find my constant of proportionality, which in this case is just k, and also the equation. And they tell us that y varies inversely as x. So y varies inversely as x. Well, what that's going to mean is that y is equal to k times 1 over x, or k over x, whichever way you want to think about it. So since they vary inversely, that means that now as one grows, the other one decreases. Okay, they also gave me some information. They told me that y is equal to 16 when x is equal to 0.3. So I have 16 is equal to k times, or rather I'll write it like this. I'm going to say k divided by 0.3. So k divided by 0.3. Okay, so I'm gonna have to multiply both sides by 0.3. So I'm gonna multiply both sides by 0.3. So that's going to become 16 times 0.3. That's 4.8. That's equal to my k. So that is my constant of variation, or constant of proportionality. And so then the equation that I want becomes y equals 4.8 divided by x. And so then imagine now, if x happens to be, let's say, bigger than 5. If x happens to be bigger than 5, let's say x is equal to 5, well then 4.8 divided by 5 is less than 1. So if x is 5, y is less than 1. If x keeps on getting bigger, if it just becomes bigger than 5, y gets smaller and smaller and smaller. So right now, these two variables are inversely proportional to each other. As one grows, the other one decreases. Okay, let's see. Let's get into the next exercise. So the amount of sales tax paid on a product is directly proportional. So right now we have directly proportional to the purchase price. So we have two things. There are two variables here. Sales tax is directly proportional. To purchase price. Okay, so first let's make sense of that statement. You gotta come up with a little equation. There's gonna be a k involved. and then they tell me that the sales tax on an item is, the sales tax on an item that sells for $119 is $7.14. What is the sales tax on an item that sells for $21? Pause the video, see if you can handle this. I'm sure you can handle it, and we'll compare answers in a second. Okay, so let's see. I'm gonna use, for sales tax, I'm gonna call it T. So T for sales tax. Although you can call it whatever, X, Y, Z, it's up to you. Purchase price, I'm gonna call it P, is purchase price. Okay, so then sales tax is directly proportional to purchase price. Let me come up with that equation that says that T is proportional, it's directly proportional, so there is a K, a constant of proportionality, times P. Okay, so that's what I have so far. I have no idea what the constant of proportionality is. Eventually, I would like to use this equation to answer the last thing. But look, they gave me more information. They told me that the sales tax, so they told me that T equals 714 when P equals 119. Do you agree? That's what this next statement is saying. The sales tax for something that sold for 119 is 714. So the sales tax is 714 for something that sold for 119. I'm gonna use this information. I'm gonna use this to find K, my constant of proportionality. So that's just going to then go something like this: 714 is equal to K times 119. Yeah, and so what I'm gonna have to do here is I'm gonna divide by 119 on both sides. And that tells me that this becomes 0.06 is my K. Okay, so now I have a working little equation now. I have this, that tax is supposed to be 0.06 times the price. I want to make that a lowercase p, otherwise it might get confusing. Okay, so T equals 0.6 times lowercase p. There we go. Okay, and so then this is my equation, and now I can use it to answer the last thing. The last thing asks me, what is the sale tax on an item that sells for $21? Okay, so I'm going to use my equation. I'm going to replace this, the price with 21 and see what the tax is. So T equals 0.06 times 21. And according to my calculator, 0.06 times 21 is 1.26. So that's the answer to the last part. How much tax are you going to pay for something that costs 21? Well, you're going to pay $1.21 at 126. Okay, so hopefully you follow this well, and we agree with the answers here. The last thing in this section. Sometimes you can have more than one variable. So far we've been dealing with only two variables. X varies directly with Y, or Y varies directly with X, but Y could vary directly with X, Y. Y could vary directly with X and Z and T and P, and so then we could have more variables involved. So this is called joint variation. So Y varies jointly as X and Z. That just means that Y equals K times X and Z. k is still the constant of proportionality. Okay, so let's see. Let's think about the next example. So I gotta find an equation of variation in which y varies jointly as x and z. Okay, so first let me just take care of that. So that means that y equals k times x and times z. Yeah, this is my constant of proportionality. Or variation. Okay, so I need to find that. I need to find that constant so that I can come up with my equation. Well, they told me that y equals 42, x equals 2, and z equals 3. Well, then let me put all of that together. So 42 equals k times 2 times 3. Okay, well, that's saying 42 equals k times 6. Divide everything by 6. And, well, then we end up with 7 equals k. Okay? So then my equation becomes y equals 7xz. And that's all there is to do in this example. All right, last little challenge in this section. Actually, no, not the last challenge. We still have a couple of them, never mind. The volume of wood V in a tree varies jointly as the height h and the square of the girth g. So let's see. So we have V. So the volume varies jointly. So then that means that there's going to be a constant of proportionality. So varies jointly with h, with the height, and the square of the girth of the tree. So what's the square of the girth? Well, that's going to be g squared. That's what we're dealing with right now. We have that the volume varies directly or varies jointly, so there's a constant of proportionality with the height and the square of the girth. Okay, so this is kind of my starting point. And then the next thing is I gotta find k. So find k. Okay, so to find k, I'm gonna use the information that they told me. If the volume is 216 meters cubed, when the height is 30 and the girth is 1.5, all right, so then that makes this equation. 216 equals k. I have no idea what k is. H is 30 and girth is 1.5. And so I'm gonna need my calculator for this. I'm gonna say 216 equals, and then 30 times 1.5 squared. And that gives me 67.5. Let me double check though. So 1.5 to the second times 30, 67.5. And then we have to divide both sides by 67.5. So divide by 67.5, divide by 67.5. And I get 3.2. Okay. So I found my k. It's 3.2. Now I have a working little equation. So V equals 3.2 hg squared. And now the last thing they ask me is, what is the height of a tree whose volume is 960 meters cubed and girth is 2 meters? Okay, so what that means is that, well, my volume is 960 equals 3.2 h. H is what I want to figure out, and then g is 2, so 2 squared. Okay, so that's 960 equals, and that's going to be 3.2 times 4, because 2 squared is 4. So 3.2 times 4, so that's 12 point, so I'm going to say h times 12.8. Then I have to divide 960 by 12.8. So 960 divided by 12.8 is 75. I guess right now we're dealing with meters. Yeah? Okay. So hopefully you were able to do that on your own, and we agree with the answer. Combined variation. So we could have a situation where y varies directly as the nth power of x. So that would mean that y equals constant of proportionality x to the n, or y varies inversely as the nth power of x. So, I mean, we already kind of had that up here in this previous example. V varied jointly with second power of g. So we've kind of already done this a little bit. So y varies inversely as the nth power of x. That means that there is a constant k such that y equals k over x over n. Let's answer the last question here. Find the equation of variation in which y varies jointly as x and z and inversely as the square of w. And y equals this when x equals that. Take a second, pause the video, see if you can figure it out. Okay, so hopefully you figured it out. You have your equation. Let's see if how mine compares. So let's see. So y varies jointly. So there's a constant of proportionality as x and z. So y varies jointly as x and z, and inversely as the square of w. Well, that means times 1 over w squared. So hopefully we were able to, you were able to at least arrive to this situation here. So y varies directly with x and z, but inversely. So now there's going to be a denominator with the square of w, so w squared. Okay, and now what I gotta find is k. I gotta find k. So this is the first thing. Let's find k. Okay, so I'm going to use all these values that they gave me to find k. So I'm going to say 105 is equal to k times 3 times 20 times 1 over 2 squared. Okay, well, that's going to say 105 equals k. Now if you multiply 20 times 3 times 1 over 4, you should get, I think, 15. 3 times 20 divided by 4, and we should get 15. And then divide everything by 15. So 105 divided by 15, and turns out that k equals 7. Okay, and the last thing is we just want the equation. So the equation becomes y equals 7x z times 1 over w squared, or you could also see it written like this: 7x z, all of it, over w squared. It's the same thing. Okay, so that is it for this section and also this chapter. So we're done with chapter 2, and I guess I'll see you at the beginning of the next chapter. Thank you.